where that ASMR stuff freaks me out. There's no way I could do that. My 6-year-old was watching ASMR video today. We're definitely not doing ASMR. We are going to practice calculating atomic particles, subatomic particles, SUBATOMIC particles. That's protons, neutrons, and electrons. Given a particular atom or element, you should be able to calculate protons, neutrons, and electrons in that atom after or by the end of this video. So we're going to start out with reviewing atomic structure. What are the pieces inside of atoms? Number 1 says to draw 5 protons. The way we're going to do that is P equals right in the middle, right in the nucleus, P equals 5. That's how we're going to represent 5 protons. Then it says to draw 6 neutrons. The way we're going to do that is N equals 6. And we've got several different types of models you'll be able to draw by Christmas break to represent atoms and pieces of atoms and eventually show bonding and other stuff, reactions happening. So the way we're going to represent the things in the nucleus, we're going to write P equals 5, N equals 6 for this one. Then it says to draw 2 electrons in the first energy level. And the way this circle is drawn, that's going to be here, but I'm going to show you a little different way to do it later. E minus, E minus. I like to put the symbols on stuff to keep track of what charges we've got. Then it says to draw 3 electrons in the next energy level. So we'll do something like this. There's 1, 2, 3 electrons in that second energy level. Then it asks you number 5, what element does this represent? And remember that the number of protons equals the element. The number of protons equals the element. ELEMENT. The atomic number is the number of protons, which tells you the element. And I have a periodic table here that we can switch back and forth to. That one had 5 protons. So if we look right here, element number 5 is boron. So we can go back to our sheet. What element is represented by an atom that has 5 protons? Boron. The atomic number, the number of protons, tells you the atomic number, tells you the element that it is. So to continue filling this in, let's label information provided in the periodic table. This top number in a box off the periodic table, if you look at a periodic table, you've got a box. This box gives you a certain amount of information. So 1 square off the periodic table, that's what we're looking at on this worksheet. This box off the periodic table, oh my gosh, come on. This box off the periodic table gives us some specific information. The number on top is the atomic number. The O here is the element symbol. I'm not having very good luck. I keep pushing things over here and it doesn't seem to want to change. This is the element name. And this one is the atomic mass, ATOMIC. You have to know the parts of a square off the periodic table and what those things represent. I should be able to ask you for the atomic number or atomic mass, and you'll be able to find those things using a periodic table. Number 7 and 8 here ask us, what does the atomic number represent? Number 7, what does the atomic number represent? So what can we tell from the atomic number? We can tell the number of protons because that's what it is. The atomic number tells us the number of protons, and in a neutral atom, you'll have exactly the same number of electrons as protons. Electrons. So for now, the number of protons and the number of electrons is the same as the atomic number. Remember, you can pause at any time. What does the mass represent? So the atomic mass here, what does that tell us? The atomic mass is the number of protons plus, not and, not or, the number of protons plus neutrons. So if we round that off to a whole number, 15.99 becomes 16, we can tell the number of protons and neutrons. There are 8 protons. How do I know that? Because right there, atomic number. And the mass of this atom is 16. So if we subtract our protons from our total mass, what we're left with is the number of neutrons, 8 in this case. The total mass of our atom is the number of protons plus neutrons. If we subtract the protons, we're left with the neutrons. And that's what it's asking you here in number 9. How would you figure the number of protons or electrons in an atom? You would use the atomic mass. Atomic number. Atomic number. Atomic number. Atomic number tells you the number of protons or electrons. I'm going to try to leave that up there. How would you figure the number of neutrons? That's where you use the atomic mass. Atomic mass minus atomic number. So atomic mass rounded off is 16, and the atomic number is 8. 16 minus 8 is 8. So neutrons would equal 8 in this particular example. So we've got a table below to practice doing this. It will be lots of fun. We've got some lithium as our element, and they're giving us pen. I don't know why that's even like that. Lithium, atomic number 3, and we can go back to our periodic table and look and see if they're telling us the truth. Lithium is right here. Lithium is right here, and it is element number 3, protons 3, atomic number 3, and it says the mass is 7, and so we're given that number. How many protons are in lithium? Protons, remember, is the same as the atomic number 3. And for now, remember that the number of electrons and the number of protons is the same, 3. So now we need to do neutrons. Mass minus atomic number. So our mass here is 7. Our atomic number is 3. 7 minus 3 equals 4. Our neutrons is 4. Phosphorus, it tells us, is atomic number 15, has a mass of 31. How many protons? 15. How many electrons? 15. Same as protons. How many neutrons? 31. Our mass minus our atomic number, 15, is 16. So 16 neutrons. I'm going to do one more. Chlorine. What's chlorine? Chlorine's atomic number, they didn't give us. Oh no, what are we going to do? Remember that atomic number is the same as the number of protons. So for all of these, you should have the information using your table somehow to fill this in. The atomic number then is 17 because we know the number of protons is 17, and we also know the number of electrons is 17, and we're given the mass. So 35 minus the protons, 17, gives us a number 18. Yes, 18. So 18 neutrons. Let me do one more for you. This, let's do some different colors. I like this green. So nickel here has an atomic number of 28. So what else is 28? The protons. What else is 28? The electrons. Now we're given neutrons and protons, but we need to solve for mass. Remember that the mass is the number of protons, 28, plus the number of neutrons, 31. So 59. The atomic mass is protons plus neutrons. All right, that should be enough for you to calculate anything else below here. So fill in the rest of this table. This potassium one here, K. You're not given the atomic number, but you're given the mass. And you can go from there. This one, you're given the atomic number and the number of neutrons. So you add those together to get the mass in this particular case. Atomic mass here and protons. Yes, this is all easily solvable. If you're not able to do this, immediately come see me. Otherwise, finish filling in this paper down to here. The bottom we're not doing yet. Just fill in this table and bring it to me to see that you either did it or you can't do it. But fill in this table down to here, and we'll get to that stuff below later on. Bring it to me so I can see that you did it, or bring it to me so that I can give you some help. ASMR video complete. If I can get to the screen to turn it off.